Hysteresis permanent magnet brakes clutches. Permanent magnet hysteresis units can be used as a torque-limiting clutch or a drag brake, depending on how they are installed. This animation will focus on two styles of these hysteresis units. The first one is the OPL series, which is factory set to have a fixed torque. These units are designed for very low slip torques. The second one is the PHT series that has a mechanically adjustable torque setting that can be changed by the user. Typical applications for OPL clutch series are paper feeds for network printers, copy machines, automatic teller machines. OPL clutches come either with a shaft or with a hollow bore, the OPL R series. OPL units consist of an integral shaft or through bore, plastic bushings or bearings for higher speed, steel housing, plastic hub, focus rings, permanent magnet, and magnetic particle powder. The OPL units use a permanent magnet or multiple magnets embedded into a plastic hub that is attached to the inner rotating member. Inside the housing of the OPL units, there is magnetic powder. The exterior of the OPL unit is steel. The magnetic particles align along the lines of flux, going from the permanent magnets to the steel housing, creating a magnetic loop, and the particles drag against the steel housing. The strength of the magnet and the amount of particles inside the cavity determine the drag torque of each unit. Larger OPL units use multiple magnets, creating stronger bonds between the magnetic particle powder and the steel housing. OPL units are primarily used in horizontal applications because in some vertical applications with vibration, particles may fall and become disconnected, which can cause loss of torque. The primary use for OPL units are for the control of paper feeds, so that if multiple pages try to feed, the clutch will slip, preventing duplicate sheets from feeding. This is critical in applications like ATMs. The second style is the PHT series, in which the user can set the unit's torque. Typical applications for the PHT series are capping machines for consumer and medical products, wire tensioning, load simulators for motor testing. The PHT units do not use magnetic particle powder, but rather a hysteresis disc to absorb magnetic flux. The units consist of an aluminum housing, end caps, one fixed, one adjustable, permanent magnets, hysteresis disc, internal sleeve or shaft, and torque adjustment bolt. A permanent magnet hysteresis clutch brake uses multiple curved segmented magnets in opposition to each other, acting on a centered hysteresis disc which is attached to the unit shaft or hub. Depending upon the size, units either use a 4-magnet disc or a 6-magnet disc. On the opposing side is an identical magnet that can be turned by about 45 degrees to go from a minimum to a maximum drag torque. In between the two magnetic discs is a hysteresis disc, which is attracted to the magnetic fields, but held apart by a spacer which maintains an air gap. An adjustment screw is used to hold the position of the magnets relative to each other. In a minimum torque condition, the magnetic discs are aligned north to south. In this case, the flux travels straight through the hysteresis disc, putting a minimum magnetic drag on the disc. In a mid-range torque condition, discs are partially rotated, so there is slightly more drag on the hysteresis disc. In the maximum torque condition, discs are rotated until the fields are directly opposing each other, so the magnetic fields bump against each other and have to travel circumferentially through the disc, putting the maximum amount of magnetic drag on the disc. By turning the movable flange magnet from 0 to 6, the flux varies from minimum to maximum, and the drag torque changes proportionately. Once the desired torque is achieved, the adjustment screw is retightened. Breakaway torque and dynamic torque are almost the same, and torque is consistent at both low and high RPM. This makes the unit ideal for tension applications like fine wire, where the material being tensioned is starting and stopped frequently. Also, there is no difference in performance in units running clockwise or counterclockwise, and the unit can be mounted in any orientation. To use the units as a torque-limiting clutch, the housing would not be fixed and would be allowed to rotate, so the unit would limit torque from the input to the output shaft, and once the preset torque is reached, the unit would slip. This makes them ideal for bottle capping applications for consumer products and medical packaging equipment. Since there is no frictional contact within the unit, no wear particles are generated. So, PHT units are ideal for clean room environments or in any application where wear particles could cause product contamination.